Assembly of pneumatic systems using step counter. Design of multi-actuator circuit using step counter method is a basic pure pneumatic circuit design. The circuits are designed according to the specific circuit sequence movement. Based on pneumatic circuit diagram, the designer will be able to identify pneumatic components, type of connections, number of components, working pressure, and etc. A skill or interpreting of circuit diagram to pneumatic circuit designs can help in circuit problem solving and will be a basic to circuit design. Circuit design testing must be done before a circuit can be applied to a system. Before we can design or do assembly on a multi-actuator circuit, we have to have the sequence movement diagram. Sequence movement diagram shows the movement we need for the system. Today we choose to use A+, B+, B-, and A-. That means the cylinder A will be extend first, followed by cylinder B, and then retract by cylinder B and followed by cylinder A. And the connection between the sensors shows when we push start button and the AO already energized, and then the A+, the cylinder A will be extended. When the cylinder A+ reach the sensor A1, and then the movement of B+ will be occur. And then the cylinder B1 will control B- and followed by BO to energize the movement of A-. After we complete the sequence movement diagrams, we can draw the circuit diagrams. The circuit diagram shows all the components we need to design the multi-actuator circuit that use movement A+, B+, B-, and A-. The circuit diagrams we need as a guide that we can assemble the real circuits. Before we can assemble the circuit, we have to mark which one we are going to do connection first. First, we have a circuit that control A+ that we mark with number 1 by side to side, and then followed by A-. And then we can make connection on B+, and last followed by B-. Okay, let's begin with completing the pneumatic circuits. The attachment must be begin with manifold. And we are going to complete line 1 of the circuits according to circuit diagrams. Okay, we begin with start push button from manifold to number 1, port number 1, and then out with port number 2 into the 3-2-way valve. And then from manifold to stop button, input number 1, and from port number 2 attached to 10 of 3 two-directional control valve. And then number 3, attach the input for 3 two-way valve. From the output, we are going to attach to AO. Output number 2 into 5 two-way directional control valve, input 1/4. And then from manifold, as a sources to port number 1, 5 two-directional control valve that control cylinder A. Number 4, to the flow control diagram, flow control valve. Okay, to complete flow control valve that control the retract of the cylinder. And then we go for line number 2 that begin with BO that control A minus. And here we use the T joints to expand the sources of air pressure from BO for output port number 2 to control A minus process. Okay, now we move to line number 3. We have A1 that control B plus. Okay, connect to number 1 as input. And then output port number 2. We have A plus here, A1 here that control B. Okay, we use another T joint. Connect to the sources air pressure for 5 two-way valve that control cylinder B. And then we attach to flow control valve, port number 2 to control the cylinder retraction. Okay, we just finished line number 3 that controlled by A1. And then last we have B1 that we are going to use to control the cylinder B retractions. Okay, connect to port number 1 as input, and then we have output. Attach to the port 1 to 5 two-way valve that control the cylinder B. The last one is attachment for line number 4. That's all for today. Thank you for watching.